All right, we're going to start on this back page of the notes. And I'm going to go through the first two steps of this proof. This is one of those two column proofs where we make the statement and back it up with a reason. So let's take a look here at this first one. Now, it says A to D bisects angle A. Well, you can tell that that is just copy pasted off the given information, so we're going to write given. Now, anytime that we are given something aside from segment this is congruent to segment that, or angle this is congruent to angle that, that is something that we will have to use. So we talk about using the given information. So we're going to use the fact that A to D bisects angle A to say what we're going to say in step 2. Okay? Well, what does bisecting mean? We know this word bisects. Since the angle is getting bisected, that's going to mean that a bisector will split the angle into 2 equal pieces. Same thing for a segment bisector. Right? We've been studying that word bisects for quite a while now. So if it bisects angle A, then these 2 angles I just marked are going to have to be congruent. That's how I'm going to get to that step, is to say this angle is congruent to this angle. So we're going from bisects to connect that to say these things are congruent. And which pieces are congruent? Well, that's angle C into A out through D, CAD, congruent to angle B into A out through D. So angle BAD. And what's my reason? How do I know that? Well, it's because that's what a bisector is. So this is definition of a bisector. That's how I know that those angles are congruent, because that's what a bisector does. A bisector is going to split the angle into 2 equal pieces. All right, so pause here. I want to see if you can do those last 3 steps. Fill out what you would need to say for those last 3 steps. All right, let's see what we have. Well, we've got reflexive property. This is the part where we look in our diagram. We look in our diagram and we look for that reflexive property. Well, where's the reflexive property? It's from A out to D. So we're going to say that A to D is congruent to A to D by the reflexive property. Then our next step is saying that CDA, that's this angle right here, is congruent to angle BDA. Well, what's our reason for that? It's because both of them are right angles. Those are both right angles. So our reason is going to be that right angles are congruent. Any right angle is 90 degrees, so it needs to be congruent to any other right angle. And then finally, the triangles are congruent. So now we need to pick out our method. Well, this bisector gave us a pair of angles, right? Those 2 angles that were split in half. That reflexive property gave us a pair of sides. And then those right angles gave us a pair of angles. So remember, we take stock of when we have what information. And we don't put that it's a side or angle until we're saying angle this is congruent to angle this, or segment this is congruent to segment this. So that's why step 1 was not a side or angle, because it didn't say that a pair of angles or a pair of sides was congruent. So we have 2 pairs of angles, and then we have the side, and that side is included between those 2 angles. So it will be angle, side, angle. Next problem down below. What theorem are you going to use to prove ABD congruent to DCA? So this is using an important idea that we're going to see in the next proof here. First off, we're going to cross off angle, 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 because that's not a method. So we can't use it. It's not on our list. So what I would do is this is something we'll use in the next proof we're about to look at, trace out those two triangles and mark out the information that you can get. Okay? So if I'm going to trace out those triangles, then I have A, B, D. That is A to B through D. That is this triangle right here in red. What have I got? I've got a pair of angles there, and I've got another pair of angles there. And I'm trying to match it up with DCA. Again, I'm going to trace out that triangle D to C through A. And tracing out these triangles lets me see what information I have. And the key thing here that you'll notice if I trace out those triangles is when I traced out those triangles, those red and blue overlapped. They had a side in common. Which side was that? It was A to D. So A to D is congruent to itself. And once again, we have reflexive property. So what do we have? We've got two pairs of angles. We've got the side, but that side is not included. It's not the included side between the two angles. So angle, angle, side is the method we would use there. Okay. So when I have a busy diagram like that, it helps to draw out that information separately. So let's look at a proof that uses this idea. All right, this is on second page of the notes. So we're being asked to prove triangle PRS congruent to triangle QSR. So I would like for you to take a minute and I would like for you to trace out those two triangles. Trace out where they are. Pause this for a minute, trace them out. Now, hopefully, where you traced out PRS, here's P to R through S, there's triangle number one. And then the other triangle is QSR, Q to S through R. And you might already notice something in the diagram, but we'll come back to it. Now, the first thing we're going to do is we're going to start by listing out our givens, as always. And if that given lists anything other than a pair of sides or a pair of angles being congruent, then we need to do more with it. Now, the good news is that the first one is saying Q to S and P to R are congruent. So we're done using that information because we're already told that they're congruent. So we don't need to do anything else with it. So Q to S is this segment right here, marked with P to R, marked with that segment right there. So these two sides are the same. We're given the Q to S and P to R are congruent. All right, then let's look at this information. This information, notice that is not saying congruent. So that means we're going to need to do something else with it. Usually using a definition that we know. So we need to look at that symbol and think, what does that symbol mean? Well, that symbol means perpendicular. So we're going to say that these segments are perpendicular. So that is P to S with S to R. So I'm going to go ahead and draw these out separately so that we can see this a little better. We have here, here, here. This is P, this is S, this is R. And we're told that P to S and S to R are perpendicular. And we're also told over in the other triangle, here's Q, here's S, and here's R, that Q to R and S to R are perpendicular. So that is Q to R and S to R. Now we're going to remember what perpendicular means. That's why the vocab is so important. Perpendicular means that when they intersect, they are going to make right angles. Right angles. And that's what you're going to say anytime you see perpendicular, anytime you see that marking, this marking here and this marking here that means perpendicular, the next thing you're going to talk about is the fact that we have right angles. And that's what's going to give you that pair of congruent angles. This means, so if P to S and S to R, that's right here, perpendicular, which means angle PSR must be a right angle. Similarly, Q to R and S to R are perpendicular. So that means that angle QRS must be a right angle. All right. So that gives us the fact that these angles are right angles, that we have a right triangle. All right. Next, you might have noticed that we have a common side. So I want you to identify, pause a minute, see if you can identify where that is and what that means we're going to say in our next sentence. Hopefully you've identified that the common side is S to R, or R to S. That side is in both the yellow triangle and the purple triangle. In both the triangles we're looking at, S to R is a common side in both triangles. That means that it must be congruent to itself by the reflexive property. So let's take stock of what information we have so that we know what method we're going to be using. All right, so I'm going to mark the information that we have both in the big diagram and in the separate triangles that I drew out. Again, drawing these separate triangles is going to be really helpful, because hopefully when we see that, when I see the tick markings here, hopefully that helps you pick out what method we're going to use. See how seeing the method in the separate triangles is much easier than seeing it in the combined triangles. And hopefully you can see that the method we're going to use is hypotenuse leg, which Q to S and P to R, this is my hypotenuse, right? It's that side across from the right angle. We need to be told that it's a right triangle, which is all of this information, right triangle. And then that reflexive property gives me the leg. So if we're looking at that information of hypotenuse, leg, right triangle, that first piece of given information told me the hypotenuse. The perpendicular gave me the right angles, which told me the right triangle. That reflexive property gave me the leg. Therefore, Let's write the congruence statement. PRS, QSR. PRS is congruent to triangle QSR by hypotenuse leg. So we saw some more complicated proofs today that used ideas of having overlapping triangles in the diagram where we had to separate out the triangles. We use the idea of bisectors today. We use that definition for perpendicular today. So really putting those terms together is important in all of these. So rest of the time will be yours to work on that next worksheet to practice some more proofs.